Hello everyone. Welcome to another exciting tutorial on an O-level topic, congruent and similar figures. In this video tutorial, I'll be covering the content as well as solving some past paper questions. Alright, so congruent figures are those figures in which the corresponding sides are equal and the corresponding angles are also equal. Then we say that the two figures are geometrically congruent. If we know that the two triangles are congruent, for example, ABC is congruent to XYZ, then the corresponding angle A must be equal to the corresponding angle of X. The corresponding angle of B must be equal to the corresponding angle of Y, and the corresponding angle of C must be equal to the corresponding angle of Z. Also, the length AB must be equal to its corresponding length XY. The length BC must also be equal to YZ, and in similar way the length AC must be equal to XY. So triangle ABC is congruent to triangle XYZ over here. Now in this example, two figures are given to you, and let's say it is given to you in the question that the figure ABCD is congruent to figure WXYZ. So if that is the case, then the angle ABC, this angle, must be equal to the corresponding angle which is WXY, which is this, and the value should be 80 degrees. Now the angle XYZ corresponds to angle BCD, therefore the value of this angle must also be 60 degree. Let's talk about the length. The length AD, which is this length, that corresponds to W. The length AD corresponds to WZ, so AD is equal to WZ, which is equals to 2 centimeter, and the length WX, which is this length, corresponds to AB. So the value of AB would be equal to 4 centimeter. So guys, now there are certain tests for congruency, and these are, let's say you have two triangles. Let me name this triangle ABC and this triangle XYZ. So if you have been given two sides and an included angle of one triangle, so let's say this side and this side is equal, the other side and this other side is equal, and you have been given an included angle, which means that two sides and the included angle of one triangle is equal to the two sides and an included angle of the other triangle, then such figures are congruent according to side angle side test. Similarly, if you have all corresponding sides equal, this side is equal to that side and this side of the triangle is equal to this side, so we have all the corresponding sides equal, then we will say that the two triangles are congruent because the three sides of one triangle is equal to the three sides of other triangle. So if this triangle was ABC and this triangle was XYZ, you can say that the triangle ABC is congruent to triangle XYZ, and you will write SSS test satisfied. Moving on to the next concept, that is angle side angle. Now let's say if you have been given two base angles, two angles and a side of one triangle is equals to two angle and a side of the another triangle, then as per ASA, which means angle side angle, the two triangles are going to be congruent. And the last one is a right angle triangle. If let's say you have two right angles in a triangle, and the hypotenuse is equal, and one of the side is also equal, corresponding side is also equal, then the two triangles satisfy RHS test, which means right angle, hypotenuse and side. So both triangles are right angle and the hypotenuse, and one side of one triangle are equal to the hypotenuse and corresponding side of the other triangle. Now let's look at one question. In this question, there are two quadrilaterals that are congruent. The lengths are in millimeter. We are required to find the values of the unknowns x, y and z. Now when they say that the two quadrilaterals are congruent, that means that the corresponding sides must be equal and the corresponding angles must be equal. So let's start with the side x. The side that has a length of x is congruent to this side, because there is 190-degree angle being formed and this angle corresponds to this angle. So the value of x in this question would be 45. Moving on, as for the angles are concerned, the corresponding angles are equal. So if this angle is 78, then this angle must also be 78, because these two are the corresponding angles. Now we have a quadrilateral in front of us in which we know all the angles of a quadrilateral except for z. So when you sum up all the angles in a quadrilateral, the sum must be equal to 360. And from here you can find the value of z, and z comes out to be 115 degree. Now let's move on to the calculation for y. Y is this length adjacent to the angle z and 90 degree. So over here we have this length. The length corresponding to y is 20. Therefore, if we know that the two figures are congruent, then the length of y must be equal to 20. Now let's try another question. In this question, these two triangles are congruent. The lengths are in centimeter, correct to the nearest 0.1 centimeter. We need to find the unknown values of p and q. Now p corresponds to this length, whereas over here p should be this, because these two are the corresponding lengths. If you don't figure out the value of p immediately, try solving for q first. This angle q and this angle is 62. Here we have an angle of 41. Okay, so this angle must be 41 degree. In the sum of all the angles of a triangle is 180. So when you add all the angles, the sum should be 180 degree, and you can get q value from here, that comes out to be 77 degree. And p corresponds to 3.8, because these two are the corresponding lengths. So the value of p is 3.8 and the value of q is 77 degrees. So let's move on to the concept of similar figures. Similar figures are those figures in which the corresponding sides, so first of all, the corresponding angles are equal. So the angle A must be equal to angle x, angle B must be equal to angle y, and angle C must be equal to angle z. This is when we have similar angles, similar figures. But in similar figures, the sides are proportional, which means that if we have side AB and the corresponding side of AB is xy, so the ratio of AB over xy must be same as the ratio of AC over xz. So AC upon xz must also have the same ratio as BC over YZ. So when the three ratios are exactly the same, you can say that the two triangles are similar. And this is also one of the tests for the similar figures, which I'll be covering in the later section of the video. Yeah. So let's look at this figure. The two figures are cube, but these two figures are similar to each other. This this length, this cube is of side 2 units and this cube is of side 8 units. Now these two are similar figures because the sides are proportional. Let's say if I take this side and if I take this side, the ratio is 2:8, which simplifies to 1:4. Also, if I take this side, this base and this corresponding side, the ratio will still be the same, that is 1:4. So I can say that the two shapes are similar. Now the angles will always be same. The corresponding angles will always be same. So this was one of the example of a similar figure. Also, here we have two cones that are similar to each other. Now when you know that the two cones are similar, then this means that the ratio of their corresponding lengths must be equal, which further indicates that if you have two radiuses, the ratio of the radius of the two cones must also be equal to the ratio of their height. You can This is very powerful tool to help you in calculation of the questions. Also, let us consider this example in which triangle DEF is similar to triangle DGH. If we know that the two triangles are similar, then we know that the length of DE over DG, the ratio of DE over DG must be equal to the ratio of EF upon GH. The corresponding side ratio must be equal. So DE over DG, EF over GH and DF over DH. You can also see this from the diagram. DE corresponds to DG, DF corresponds to DH and EF side corresponds to GH. So it must be the same, it must have the same ratio. Okay, so now let us go quickly over similarity test. How would you test for the two figures to be similar, or how would you prove that the two figures are similar to each other? There are certain tests that can be identified to prove that the two figures are similar. Now, when we are talking about similar triangles, if you have two angles of a triangle are equal to the two corresponding angles of another triangle, then the two triangles are similar, which means that if two angles in this triangle are equal to the two corresponding angles of this triangle, then the two triangles are similar. We don't need to prove the third angle, as the third angle will automatically be the same because we know that the total sum of the angles in a triangle is 180. So if we know that this angle is 70 and it's an isosceles triangle, this angle must be 70. And if you work out using the sum of the triangles, you will come across the fact that this angle is 40 degree. Similarly, if you know that this angle is 40 and you have an isosceles triangle XYZ, this angle comes to 70 degree. So now you can say that triangle ABC is similar to triangle YXZ. Okay, so the angles are similar. So if the two angles were similar, if you are able to show this, then you satisfy the AA similarity test. The other similarity test is the side-side test, side, which means that if the three ratios of the corresponding sides of the two triangles are equal, then the two triangles are similar, which means that if you are able to show that all the ratios of all the three ratios of the corresponding sides are same, then the two triangles must be similar. So in this triangle, the ratio of AB over YZ must be equal to BC upon XZ, which must be equal to AC upon XY. Okay, so AB is 7.5, YZ is 3, BC is 15, XZ is 6, AC is 10, and XY is 4. So if you work this out, the ratio will come out to be the same, that is 5 upon 2. So if we know that all the three ratios of the sides are equal, then we say that the two triangles are similar as per the SAS Similarity Test. Moving on, the other test is SAS Similarity Test, which is that if you know that the two ratios are of the corresponding sides of the two triangles are equal and a pair of included angles are equal, then the two triangles are similar. So let's say triangle DEF is similar to triangle DGH. Okay, so let me write this down. DEF is similar to triangle DGH because angle D is a common angle. Okay, that's an included angle, and the ratio of DE upon DG must be same as DF upon DH. So if you have two sides, if you have two ratios of the corresponding sides and a pair of included angle, then according to SAS Similarity Test, the two figures will be similar to each other. Now let's look at some questions. Alright, so in this question, OYC is a triangle. OYC is a triangle given to us. A is a point on OY and B is a point on CY. AB is parallel to OC and AC and OB intersects at X. The question says prove that the triangle ABX, which is this, ABX is similar to triangle COX. COX. Now we need to prove that the two triangles are similar. And the way you are going to go about this question is you will first we know that the lines AB and OC are parallel, so look for the alternate angle. We know that this angle must be equal to this angle and this angle must be equal to this alternate angle. So you also have to give a reason for your answer. So you can write ABX, angle ABX is equal to COX, and in the bracket you can give your reason that it is an alternate angle. Alternate angles are equal. Also BAX angle is equals to OCX. BAX is this angle and it's equals to OCX. Again the same reasoning, alternate angle. And last, AXB is equals to CXO, and this, the reason is this angle is equal to this angle because it's a vertically opposite angle. So when you have three triangles, three angles equal, you can say therefore triangle ABX is similar to triangle COX. And if two angles were equal, this satisfied AA test of similarity. Now in this slide, let us look at the area and volume of similar figures. Let us consider the same example in which we have a cube of side 2 centimeter and we have a cube of side 8 centimeter. The length, since it's a cube, all the lengths are same and all the lengths are same. If you try to find the volume of this cube, the volume is given by L cube. So the volume of this first cube will be 2 cube, that is 8. And if you try to find out the volume of the second cube, 8 times 8 times 8, you will get 5112. Okay. Now if you were asked to write down the ratio of the volume of V1, which is this, over V2, you would have written 8 over 512, right? You could have gotten this answer using the ratio of the length by just taking the ratio of the length, which is corresponding lengths are 2 over 8, and then cubing it. So 8 over 512. So we can say that the ratio of the volume of the two geometrical similar figures is equal to the ratio of their corresponding sides. Similarly, if you have area, so the area of this face of the cube is 4 and the area of this face of the cube is 64. If you were asked to figure out the ratio of the two areas, you would have written 4 over 64. You would have gotten this answer just by taking the ratio of their corresponding lengths, which is 2 over 8, and then squaring it. So 4 over 64. So the bottom line is that the ratio of the area of the two geometrical similar figures is equal to the ratio of their corresponding sides is equal to the square of the ratio of their corresponding sides, and the ratio of the volume of the two similar figures is equal to the ratio is equal to the cube of the ratio of their corresponding sides. So for mathematically similar shapes, area scale factor is just the length scale factor का square. Volume scale factor is length scale factor the whole thing cube. Now let us take another example, this time of a cone. These two cones are geometrically similar. So if these two cones are similar, then as for the length, the ratio of the heights h1 over h2 must be equal to the ratio of the radius r1 over r2. As for the area of the two circles of base circles of the cone, the ratio must be equal to r1 over r2 the whole thing square, or you can also take h1 over h2 the whole thing square. For volume, the volume of the two cones must either be equal to the ratio of the cube of the radius, or r1 cube over r2 cube, or you can say r1 over r2 the whole thing cube, or h1 over h2 the whole thing cube. Alright guys, so let's look at this another question in which in the diagram triangle APQ and ABC are similar. The question has itself told you that the two triangles are similar. BC is parallel to PQ, so this length is parallel to this length. So if these two, and also these two are the corresponding lengths, so the ratio of the corresponding lengths in the similar figures are equal. You are given that BC is parallel to PQ, AP is 4 centimeter, PB is 2 centimeter, and PQ is 1.8. you have been asked to find the length of BC. If we know that triangle APQ is similar to triangle ABC, then the corresponding lengths must also be, the ratio of the corresponding lengths must also be equal. The length that is given to us is AP, so we will take the ratio of AP over AB is equal to PQ upon BC. So the value of AP is 4. The value of AB is this entire length 6. The value of PQ is 1.8. The value of BC was unknown, and you can cross multiply and figure out the value of BC. So I get 2.7 centimeter. Moving on, for the second part, you are asked to find the ratio of the area of the triangle APQ, which is this, over area of the quadrilateral PBCQ. So let me tell you how to go about this question. First of all, you will find the ratio of area of triangle APQ over area of triangle ABC. Now the triangle APQ and ABC are similar, therefore the ratio of the areas must be equal to the ratio of their corresponding lengths. So the corresponding lengths are AP and AB. So AP is 4, AB is 6, and the whole thing square. In this way, you will get the ratio of their areas, that comes out to be 16 over 36. Then you can find the area, then you can find the ratio of the area of triangle APQ over triangle, over the quadrilateral PBCQ. Now we know that the entire triangle, the larger triangle ACB or ABC, can be divided into 36 parts, out of which APQ is 16 parts. So the remaining parts for this quadrilateral must be 36 minus 16, that is 20. So the ratio of the areas of the triangle APQ over the quadrilateral PBCQ would be 16 over 20. And if you simplify this, you get 4 over 5. Okay guys, now I have already solved this question for you. I'll go over the solution and try to explain it in detail. A and B, BLC and CMA are straight lines. NM is parallel to BC and LN is parallel to CA. So they have given you this, that NM is parallel to BC and LN is parallel to CA. We are required to prove that the triangles A and M is similar to triangle NBL. So I have highlighted these two triangles. You need to show that A and M is similar to NBL. Now recall all the similarity tests. You will notice that since these line NM and BL are parallel, we can have alternate angles over here. We can have corresponding angles over here. So A and M, which is this angle, let me mark for you, should be equal to NBL because of the property of corresponding angles. Similarly, AMN must be equal to NLM, again corresponding angles. So when you know that the two triangles have two corresponding angles equal, then as per AA similarity test, the two triangles are similar. So you can write, therefore triangle ANM is similar to triangle NBL. Because also the third angle would be equal, because if you know that the two corresponding angles are equal in the two triangles, then the third angle can be found out by adding the two angles in one triangle and subtracting it from 180 degree, because the total sum of a triangle is 180 degree. Therefore the third angle must come out to be same. Let's move on to the next part. In the next part, you were asked to find the ratio of AN is to NB. Sorry, you were given that AN ratio NB is 2 is to 3. You are being asked to find NM is to BC. So the NM is this length. NM is to BC ratio needs to be found out. So we know that A and M is similar to triangle ABC. A and M is similar to triangle ABC. So A and M, this triangle is similar to triangle ABC. If that is the case, then the ratio of NM is to BC must be equal to the ratio of AN over AB. See the corresponding lengths. NM corresponds to BC, so NM over BC ratio must be equal to AN over AB. And we were asked to find NM is to BC, so we will go back to our diagram and figure out the ratio of AN and AB. So AN, in the question we were given that AN is 2 and NB is 3. This makes AB 5. So the ratio of AN over AB must be 2 over 5. In the next part, you are asked to find the area of ANM to area of NBL. Area of ANM, which is this, ANM to area of NBL. NBL. Now these two are similar figures, therefore the ratio of the areas must be equal to the ratio of the square of the ratio of their corresponding lengths. Therefore this triangle has a length of 2 and this triangle has a length of 3. Let me just change the color. This triangle has a length of 3. Therefore the ratio of the areas of the two triangles would be 2 over 3 the whole thing square, which is 2 square is to 3 square. Since the ratio of the corresponding lengths was in the ratio of 2 to 3, the area would be squared. So 2 square 4 is to 9. Then in the last part, you are asked to find the area of triangle ANM is to area of NMCL. Let me mark the figures first. ANM is this triangle and NMCL is this figure. So the way you go about this part is, you first of all find the area, the ratio of the area of ANM and ABC, ANM and ABC, and these two triangles are similar, so the ratio of the areas must be equal to the ratio of the side. The corresponding sides are AN and AB. So 2 the side AN is 2 and the side AB is 2 plus 3 5. The ratio is 2 over 5. The area's ratio would be 4 over 25. Similarly, if you have triangle, then you will find the ratio of the triangle NBL and ABC. So NBL and ABC are also similar. The ratio of NB, side NB is, the value of the side NB is 3, and let's say the value of the side AB is 5. Basically these are not the exact lengths, these are the ratios. So the ratio is 3 is to 5. So if the ratio is 3 is to 5, then the ratio of the areas would be 9 over 25. Okay, now think it in these terms, along these terms. If I have triangle ABC and I have 25 parts of it, out of these 25 parts, I know that triangle ANM is 4 parts, triangle NBL is 9 parts. So this quadrilateral NMCL would be the leftover parts, which is 25 minus 9 minus 4, 12. Now this is the ratio, this is the distribution of the areas. So out of 25, 4 refers to triangle ANM, 9 refers to NML and NBL, and 12 refers to NMLC. You were asked to find the ratio of the area of ANM and NMCL. So I know that the ratio of the areas would be 4 is to 12, which simplifies to 1 is to 3. Okay guys, so let's consider another question in which ABCD is a parallelogram, ABCD is a parallelogram, BEF, BEF and CDF are straight lines, AB is 4, DF is 2 and AE is 5. You need to show that the triangles ABE, which is this, ABE is similar to CFB. If that is the case, then you will have to identify the angles first. So we know that BEA, which is this angle, BEA must be equal to FBC because these BC and AD were straight lines, parallel lines. Therefore, the alternate angle is being formed, which is BEA must be equal to FBC. Also, ABE, which is this angle, must be equal to CFB because AB and FC are also parallel lines. Again, an alternate angle is formed. So when two corresponding angles of a triangle are equal, the third angle would automatically be equal. Therefore, it satisfies AA similarity test. In the next part, you are asked to calculate BC length. Okay, this here is the length of BC. Now BC is similar to AE plus AD. It's a parallelogram and we know that the opposite lengths in a parallelogram are equal. So BC must be equal to AD, which is AE plus ED. Okay, and AE is 5, ED is unknown. Now let's look at the solution. We have identified the two pairs of similar triangles that are, we know that EFT is also similar to BFC. When these two triangles are similar, then the ratio of the corresponding sides must be equal. So let me mark this 4 because in a parallelogram opposite lengths are equal. So, this length would be 4. So, the ratio of FD upon FC must be equal to ED upon BC, and as from the diagram you can see that the values are 2, 2 and the value of FC is 6, ED is unknown and BC can be split up in 5 plus ED, and you can solve for ED which comes out to be 2.5. When ED is 2.5, the total length of AD will be equal to BC, which will be equal to 7.5, because BC is just equal to AD, which is the sum of AE plus ED. If AE was 5, ED was 2.5, then BC would also be 7.5. Now, in the last part of this question, the question says that triangle DFE is also similar to triangle ABE. Given that the area of triangle DFE is x centimeter square, find the area of ABCD in terms of x. So, let me tell you how to go about this question. First of all, mark triangle DFE and ABE on your diagram. DFE and ABE. DFE and ABE. Okay. You have been given that the area of DFE is x centimeter square. You need to find the area of ABCD in terms of x. So, first of all, find the ratio of the area of triangle DFE and area of triangle ABE. So, these two triangles were similar, the ratio of their areas would be equal to the ratio of their corresponding length ka square. So, DF upon AB was 2:4, squaring them would give you 4:16. Area of DFE in the question is given to you as x, area of ABE, you cross multiply, you get the area of triangle ABE in terms of x, that comes out to be equal to 4x. Now, area of DFE, then you find ratio of area of DFE over area of CFB. CFB, the corresponding lengths would be DF and CF, or FE or FB. So, the corresponding lengths in the question is given to us as 2:6. So, squaring them will give you the answer 4/36. Now, consider this thing. Consider the entire triangle CFB into 36 parts. Okay. And out of those 36 parts, 4 parts refer to the area of DFE. Triangle X, okay, so DFE was x, CFB was unknown, the ratio of was 4:36, you cross multiply them and you get the area of CFB as 9x. So, we have the area of CFB and area of ABE in terms of x. ABE comes out to be 4x and CFB comes out to be 9x. This was already x, and the entire CFB was 9x, leaving this area 8x. Now, you were asked to find the total area of ABCD in terms of x. So, ABCD in terms of x would be 4x plus 8x, because we want to find it for the entire parallelogram. So, 4x plus 8x in terms of x will give you 12x, which is here. I hope this video was helpful for you. Thank you.